Okay, continuing our discussion about sources, there are two types of sources. We have independent sources, which are experimentally sources which we can swap out and maybe change. And we have dependent sources, which are sources which we can't we can't take out of the system and they're part of the model. For independent sources, there's a few kinds of independent sources. You have your conventional independent voltage sources, you have your conventional independent current source, and then you have an AC source to go with it. There are other independent sources like maybe a pulse signal or maybe some weird triangular sawtooth, maybe an exponential signal. But in general, we don't cover these mainly because they're outside our scope of analysis. In order to be familiar with AC sources, we have to be familiar first with the DC sources. So we have the independent voltage source right here, independent voltage source. And then we have same thing here, but for current. These quotations are just to mimic writing this without having to write it again. Now, what about dependent sources? So dependent sources are non-physical models that are part of the circuit and we can't take it out. Usually they come in the form of a diamond, like so. Or they so this would be considered a dependent voltage source. And then maybe this would be considered a dependent current source. Now, there are four types. This could be current controlled. So it could be controlled by current. It could be controlled by voltage. And this could be controlled by current. And this could be controlled by voltage. The reason why, as mentioned before, why they exist is because they're part of a circuit model and something that we can't get rid of. Now, I won't go into the details, but you'll see that it is important, especially for modeling, for this famous picture of the small signal amplifier as given below. So this picture is only becomes significant when becomes a significant need or becomes significant in needing to model its AC load line. And as such, the AC load line comes with dependent voltage sources or dependent current sources. This right here, the AC source, is part of an independent source. And just in general, anytime you need to model something, the dependent voltage source usually might be involved. Now, one other thing to also talk about is you can kill independent sources, but you can't kill dependent sources. This might be useful for finding equivalent something. Equivalent, let's say, equivalent something. So, for example, it might be used for finding equivalent resistance or equivalent capacitance or equivalent inductance. Or if you're talking about RC, LC, RL, finding something or an equivalent resistance so you can model it with the time network. Unfortunately, with dependent sources, you can't kill them at all because they're part of the model. Okay, thank you.